Hey guys, so in this tutorial we're going to be looking at how do we create an infinite horizon past the extents of the playable terrain, and we're going to be doing that with Houdini. We're going to be using the Labs toolset, and we're going to be using a node called Mapbox. So in this tutorial you're going to learn how do we take the area outside of the playable terrain and extend it all the way up as far as the eye can see. It's just a short tutorial. We're not going to cover optimization this time. We'll be looking at it the next time, but you'll be able to get something inside of Unreal by the end of this video. So if that sounded like your thing, good luck, and let me know what you think in the comments. So the tool we're going to use inside of Houdini is going to be called the Mapbox node. Now you can see it's called Labs Mapbox. So if you tried to search for the Labs Mapbox node and didn't find anything, it's probably because you haven't got the Labs toolkit installed. The Labs toolkit, I'm just going to Google it. Side effects, Labs is an amazing set of tools which is largely focused towards people producing content for games, which just does so much. This is a set of HDAs, Houdini digital assets, which have been designed by an internal team at Side Effects, and they've just built all sorts of amazing functionality inside of them. If you go and have a look at this page and take a look through, you're going to see there's just absolutely tons. Here you go. Here's the list of them. Just all sorts of things, from photogrammetry to projecting sort of high resolution to low resolution meshes, calculating occlusion, generating cables, building generators, just so much. And one of the tools that they added inside of this is the Labs Mapbox. So that's what we're going to use today. The way that you can install the Side Effects Labs toolkit is you go up and hit this little plus icon at the top of the sort of on this shelf here, and you're going to click Shelves. Then you're going to go down and you're going to tick the Side Effects Labs shelf. That's going to create this additional shelf here, and you won't have any of these buttons. You'll only have one of these buttons to start with, the Update Toolset button over here. So you're going to need to press that. That's going to create this little dialog box, and you're going to hit Update. And once you've hit Update, you need to restart Houdini, and then suddenly you're going to have access to all of these tools that come as part of the Labs toolset. So this is a must-have resource for anyone who's working with Houdini, just in general, I would say, especially if you're working in games and in Unreal, but just in general, this is an amazing set of tools. So once we've got the Labs toolkit installed, we're going to search Mapbox. And Mapbox is an online, it's a sort of I don't know what you call it really, an API for accessing data from for open source satellite data online. And if we change the preview to the Mapbox here, we're going to get an error by default. And that's, well, I think that might just be because we haven't actually looked up any terrain. But if we press look up, you're going to see we get this warning, which is an API access token is required to use Mapbox. So how do we go about getting an API key? Well, it's quite simple. We just search Mapbox API key. API Mapbox. And let's have a little look. So I've got an account. You just have to make an account. You jump in, and there's a default public token which you can use here. So you can just copy this one, although that's going to be a bit of a pain. Or you can just make an account for free and download it there. So once you've done that, go into Mapbox, click this little plus icon next to API key. We're going to paste it in. And now when we press look up, you're going to see that we get this map. We get the Earth map, and we can just zoom in wherever we want on the entire world and have access to a roughly 30-meter precision digital terrain model, DTM. Now, I can't remember exactly where I got my terrain data from. I need to match it exactly to the LiDAR data so that I can create the seamless transition from one to the next. So what I'm going to do is I'm just going to go back to the downloads folder where I downloaded the DTM files, and I'm going to make a note of the name of the tile, which is NY12SW. I'm going to go back to the DEFRA survey data, and I'm going to paste that in there. And it's going to jump us straight to where those tiles are. I'm going to zoom out so I can see where that is. And I can see that's in the Lake District National Park, and it's quite close to Whitehaven. And it's actually right adjacent to this lake here. So now we're going to go back into Houdini. We're going to zoom into that similar region. So Lake District National Park. And I can see there's a lake there. I don't know if that's the right lake. So I'm just going to zoom in a bit further. I'm going to zoom out again, actually, first. Maybe I've gone slightly too far up. Again, my geography is not my strongest point, I've got to admit. So that's definitely the right area. And we're going to zoom in, zoom in, zoom in, zoom in, zoom in. And I wonder if this is the lake that we're looking at there. I think that's the one. So this is this lake. So we know that we've got the NY12SW, NY12SE, and the NY11, I believe. Yep, that's right. So it's these 4 tiles that we've got. So around these lakes. So if I jump back to Houdini again and zoom out a little bit, we're basically just going to zoom out a little bit further so that we encompass a larger area of the terrain than we were getting just with that LiDAR data. And we're going to keep it relatively, if we can, relatively centered on the center point of those 4 LiDAR tiles. There we go. I'm going to jump out. I don't know how many steps that was, but I'm going to jump out a few steps. I'm going to hit download. Now this download is going to take a long time. So I'm going to fast forward the video here. Hey guys, so while that's downloading, it's going to take a little time because they're big files coming into Houdini. I'm just going to take this opportunity again to ask you to please like and subscribe if you find these videos interesting, informative, or entertaining. I've got a lot more content planned, foliage production inside of Houdini. We're going to be looking at how do you use spline tools, amongst other things. And of course, I'm going to carry on with this series where we're looking at how do we go from 0 to like Z with making terrains, like going all the way from raw, scratch, nothing, up to something which you could feasibly imagine seeing inside of a AAA game. If that sounds like your thing, please stick with it. And yeah, I'll let you get back on with the tutorial. Okay, so I timed that and it took about 10 minutes for me to download here, but I'm currently working somewhere with very, 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 very slow internet connection. So you can see we've just got that huge, enormous section of the UK. If we zoom in, the data's textured, but we're not going to use the text data. And it's very, very low resolution, but that's fine. So first thing I'm going to do, if we press I here, we can just see that we've got the mask and we've got the height. But we've also got up here in the primitive attribute section, name and shop material path. So this shop material path, the material is what's currently applied to the height field and is giving it the colors. So we're going to create a node called attribute delete. You can search ATD to find the attribute delete. And I'm going to plug that in there. And you can see, remember, it was a primitive attribute. So this attribute delete allows me to clear certain attributes from the geometry. And I'm going to go over to the far right of this input box here and click the down arrow to look at the ones we currently have available. And I'm going to delete the shop path there. And if we change the focus to attribute delete now, we've cleared that and we're just left with all this lovely juicy Heightfield terrain data. So what's the next step? So this is where we're going to start getting a little bit more into the weeds with Houdini. What we need to do is we need to take this data, convert it into a mesh, and we need to split it up in such a way that it's going to be efficient when we run it inside of Unreal. We can't just import an enormous height field and have it always be visible no matter which way you're looking. You can imagine if we're standing in the middle of the terrain here and looking off in this direction, then we're going to be drawing the entire terrain, even what's behind us, because it's not split up in any sort of way. Well, that's going to be the second step. The first step is we're just going to cut out a portion of this terrain, blend in the high resolution terrain in the middle, and we're going to get it displaying inside of Unreal. Okay, so how are we going to do that? Well, first thing we're going to do is we're actually going to convert this into a mesh. So I'm going to create a convert height field node. The way to do that is I right click and type convert to bring up the menu for convert height field. We're going to plug this in here and we're going to change nothing about it. No, nothing about it. We're going to leave it as is. And we're going to leave the density at 1 for a time being. Okay, so now that's converted this into a mesh. If we look at smooth wire shaded, you can indeed see that we've got triangles, or quads, I should say. So we can switch back to smooth shaded. Now we need to basically cut out a portion of this terrain that corresponds to where our LiDAR data is. But in order to do that, we first need to make sure that they line up. They're the same kind of scale. So I'm going to create, over here, the Heightfield project, I'm going to create a node called Null. I'm actually going to do that after the file cache here. So I'm going to create a Null node. I'm going to slide that into each of these. So I'm going to replace those inputs. And we're going to rename this Null node. So you just right click and type Null to find a Null. Null does nothing. It's just a way to remain organized. I'm going to select the Null node. I'm going to call this out Heightfield High-Res, like so. I'm then going to press, with this selected, and press Z on the keyboard. I'm going to change it to a circle because I like circles. And I'm going to set the color to blue because I like blue. There we go. And now we basically want to access this node, but without having to pull out another wire, because if we start pulling out tons of wires that go off to do different operations in different parts of the node graph, things are going to start to get a little bit messy. So we're going to right click again. I'm going to create an object merge like so. I'm going to set the color by I'm going to select it and press C and change it to blue so it matches the color of the Heightfield High-Res. And then with this selected, I'm going to left click and drag. So I'm going to hold left click and drag the Heightfield High-Res and drag that into object 1 there. And now if I look at the preview of the High-Res and the preview of the object merge 1, we can see they're the same thing. And you can actually visualize the connection between these two nodes. If we go up to view here, and we can see dependency links show for all nodes. And you can see it's got this little brown node connecting it. I don't need that, so I'm going to go and I'm going to turn that off because I know they're connected because I set them to be the same color. I'm going to go and drag that up here into this new kind of workspace that I've created for the low resolution terrain. So this is the workspace for the high res. This is the workspace for the low res. And we've got this geometry and we've got this geometry. And I basically want to have a look at both of them at the same time. So I'm going to keep the focus on the height field because if I change the focus to the convert height field over here, the mesh, and I preview this one, we can't see anything. There is this little orange grid that's sort of overlaid on the grid there, a little orange rectangle. But actually, if I look at them the other way around, if I look at the height field data truly, and I look at the grid for the convert height field, you can see both at the same time. Although potentially this is still not actually going to be the easiest way to see how they match up. So how are we going to do this? How are we going to make this work? I think they might actually... No. Okay. So what I'm going to do, I'm just going to make a merge. Let's have a little look. There we go. And we truly will just draw them over each other. And this could get a little bit tricky because we need to find the part of the terrain that this bit slots into. So I'm going to make a transform node here next to the convert height field. There we go. A little bit slow. And we're going to start moving this around. And okay, so I think I've realized what was making this so hard to line up. The thing that was making this so hard to line up is the fact that the rotation is the wrong way round, or they don't match rotation. So I'm going to switch back to the transform over here, and I'm going to rotate that by minus 90 degrees. Oh, not in that axis, in the Z axis. I'm going to rotate that by minus 90 degrees. Have a little look. Jump back to the previous one. So that is now oriented, yes, the same way as the def red data. And if we have a look at the transform, I can see that same shape there, finally. Okay, so at this stage, it's going to become hopefully a lot easier. Okay, so I'm reasonably content with that. And notice how it could probably be a little bit better, actually. I'll play a little bit more. But notice how the vertical scale matches almost exactly. And that's because we haven't faffed around with it. We've just gone straight from the LiDAR. We've made sure that it matches the actual dimensions in meters. And the height is already correct from both the GeoTIFF and from the Mapbox data. So this saves a ton of time. All right, so I'm happy enough with that. I'm going to leave that there. So at this stage, we need to just cut out the high resolution from the low resolution terrain. That's going to give us our very first draft. I'm going to create a node called bound. And bound is just going to go around the high resolution terrain like this. What we're going to do is we're going to use a Boolean operation, Boolean subtract, and we're going to subtract the bound from the mesh that we created from Mapbox. You can see subtract A minus B, and we're going to treat the Mapbox data A as a surface. We're going to treat the box as a solid. It's going to take a moment. The Boolean's quite slow. I actually decided to cancel out of that because we've got this mesh, this convert height field mesh here, which has how many polygons? Let's have a quick look. 4 million polygons. And frankly, a lot of those are just wasted because we don't see them in the uniform grid that we're getting from the height field. So I'm going to apply a Polyreduce operation just to speed everything beyond this stage up a little bit. I'm going to focus the Polyreduce before I've even applied a reduction. And what that's going to do is it's just going to pre-analyze the geometry. Now that it's analyzed the geometry, I think I could get away with a reduction of something like 20, down to about 20% of the input data. That took a little while too, but you can see that if we flick between the raw conversion and the Polyreduce, there's barely any noticeable difference. But if we switch to the wire shading, you can see that we've got a vast reduction in the density of the polygons. And if we hit I over here, we're now down to 500,000 points instead of 4 million. And I'm just going to push it even a little bit further. Notice how the poly reduction picks up where it leaves off, so you don't have to recompute the entire reduction every single time you change the percentage. Okay, so I'm a lot happier with that now. I'm going to switch back to smooth shaded, and we're going to rerun that Boolean, and it should go an awful lot faster. There you go, almost instantaneous. So it's worth doing a reduction if you can before you try and do anything with Booleans. Okay, so we've snipped out a portion of the terrain which corresponds to where our high resolution terrain is. So let's, instead of merging the pre-Boolean terrain in with our high resolution, the pre-Boolean background in, let's merge in the Boolean version instead and see how that fits. Okay, so yeah, it's not perfect, but it's starting to get quite close to being a good match, but we can do even better than this. So let's take this one step further. First off, let's go up to this bound node and let's decrease the let's do some inverse padding on each axis, and I'm going to set that to be 10. But before I do that, I'm going to go back and make sure I'm on manual mode so that it doesn't update while I'm changing all of these values. And now I'm going to go and hit on mouse up again. Okay, so I've done that in the wrong direction. So we've got the padding, we've got it lining up in the we've got it lining up like overlapping by 10 meters, although that's a very small amount, you can see there. But the problem is that the vertical axis is completely off. Now, I could spend an awful lot of time kind of going through and trying to perfectly line this up, but I'm just going to take a bit of a shortcut. And what I'm going to do is I'm going to basically blur the high resolution data into the low resolution data so that we offset the height in this region. So the way I'm going to do that is after the Polyreduce, we're going to insert a new node called Ray. No, we're not. We're going to do it after the transform, because otherwise it won't line up correctly. We're going to insert a new node called Ray. I'm going to pull this bound down here so it's out of the way, and we're going to use the Heightfield as our collision. And we're going to see, ooh, switch back to find where the bounds are. I can actually set this to preview so I always know where they are. There we go. And let's have a look at the result before and after a ray. We need to set the method to project rays and the direction. We just want to shoot it directly up rather than using the normal axis. So I'm going to delete the ray direction here. I'm going to right click this channel ray direction, click delete channels to clear those of their preset values. And we're going to choose 1 in the y axis, which is up and down. And then we're going to try to reverse the rays. And there you go. You can see now that that's shunted it down to match where the actual terrain is. So if we have a little look at this result of the merging again, we can see that's getting an awful lot closer to being a snug fit. It's still not perfect, however, so we're basically going to do the same thing, except this time we're going to apply it to the low-res terrain data to the high-res terrain. So the way we're going to do that is we're going to go and create a null output from the result of this ray here before the Boolean. And just like we did over here where we created a null output for the Heightfield high-res, we're going to create a null output for the Heightfield low-res. So I'm going to wire that pin in here. I'm going to change it to a circle because I like circles, but this time I'm going to make it red. I'm going to call this out Heightfield. Last time I did all caps, so I'll do all caps again. Low res. We're going to create another object merge. I'm going to make that red too. And then we're going to select the object merge and we're going to drag the low res into the object here. And if we flip between the two, we can see they are the same thing. If we go to view and click show for all nodes, we can see they're now hooked up. I'm going to hide that dependency link there. And now I'm going to pull this over here. And after this file cache, I'm going to create another Heightfield project. After this file cache, I'm going to create another Heightfield project here. I'm going to plug the output of the file cache into the project. I'm going to plug the low res into the geometry to project. Let's have a little look at what we get. The moment, it's looking a little bit weird. And the reason it looks weird is because it's using the combine method maximum. And we don't want to do that. We want to use replace. So now we've basically overwritten all the high-res data with the low-res data from the Mapbox. But for example, if we were to plug that into the out Heightfield high-res now, that's created a dependency link. So we can't do that. We need to take this output Heightfield high-res up here. There we go. And we need to create a new null here. We're going to call this out final Heightfield. Set that to a circle. Set that to green. And I'm going to replace all of these connections in here. So we now have the Heightfield high-res, which comes straight from the input LiDAR data. That gets fed over to this object merge, which then affects the low-resolution terrain. And then the result of that low-resolution terrain is going to get fed back into this Heightfield, but afterwards. And we're going to project it back in. And the reason we can't do that before, the reason why we can't do the project before the Heightfield high-res is because then this low-resolution data would be relying on the data that came from the high-res, and the high-res would be relying on the data that came from the low-res, and we've created a circular dependency link. So basically, it's just not going to work. So we do that afterwards, and we've created this Heightfield project. And if I was to apply this now to the final Heightfield, and I'm going to create another object merge now. I'm going to make this one green to match the out final Heightfield and pull that in there. And pull that in. And I'm just going to cut this link from the high-res into the merge. This merge is going to be our preview. So we'll just plug our new final Heightfield in there. And you're going to see that that now lines up perfectly. So we've stitched the low-resolution data and the high-resolution data together, or at least we've nearly finished doing that. Okay, so what I'm going to do is I'm going to pull this off to the side here, and we're going to pull this down to make a little bit more space. And you can see that we've lost all of that juicy high-resolution data. And what we need to do is we need to blur that back in, but we want to leave the low-resolution data just in a little trim towards the edge. So the way we're going to do that is we're going to create a node called Heightfield Layer. This allows us to layer two Heightfields together, and we're going to create a mask that allows us to do to define the blend region. So I'll plug the raw high-resolution terrain into this left pin of the layer. I'll plug the new low-resolution terrain into the middle input of that. And now we're going to do something called a Heightfield mask by object. I'm going to pull that over here for the project. And then we're going to use that same bound node. We're just going to copy that bound node, which has already applied a bit of an offset. We're going to pull that over to here. And we're going to bound that, we're going to make that bound the Heightfield project there. We'll plug that into the Heightfield mask by object. You can see that's now masking everything except the very, very, very edge of the terrain. And we're going to change that to be a bigger padding region. So I'm going to minus 100, minus 100, minus 100 in all of those channels. And that way we're starting to pull it in. And I'm going to give a little bit more of a fall off. So let's do 500. Okay, and then we're going to go to that mask by object and we're going to apply a bit of a blur. I'm going to blur it by 250 units. So now we've created a nice fall off towards the edge of our terrain. And the last thing I need to do is just invert that mask so that we're only going to blend the low resolution terrain in at the very edges of the high resolution terrain. So we take the output of that mask by object and plug it in here. And then we plug the Heightfield layer and we have a little look at that. And you're going to see now we've got the low resolution data at the edges. There. And the high resolution data in the middle. And if we go and have a look at that merged result, we turn on smooth shading so we don't see the wires. And we can see that that now blends in perfectly to the exterior terrain with a little bit of an overlap region. You'll also notice that the terrain starts to look a little bit jagged here. We can deal with that in a future workshop when we tidy this up a little bit further, but that's the kind of basis of how we get these infinite horizons into our into our landscapes. So what we're going to do now is we're going to re-export all of our channels. Actually, we're just going to re-export the height for the time being. And then we're going to take the output of this Boolean and we're going to prepare this for export. So there's a few things that we'd like to do with this. What we'd like to do is first we need to make sure there are no ngons or non-manifold edges, because sometimes when you use a Boolean operation, it can create those around the border of your mesh. So what we need to do here is actually, if you remember back in the first workshop, we hid this little sidebar here. So we're going to click this little black arrow to expand it again. And then what we're going to do is we're just going to have a little look at this point preview here, and we're going to have a look at smooth wire shade. And what we're looking for is any points which are, any faces which have more than 4 points. And I think I can see one right here in this corner. So notice that we've got 1 point there, 1 point there, 1 point there. I'll do that again because I accidentally drew over it. So we've got actually 1 point there, 1 point there, 1 point there, 1 point there, and 1 point there. So we've got a 5-sided face, which isn't good for Unreal. Now we could go and manually fix that up, or we could just use a handy little node in Houdini called divide. And we're going to set the maximum number of edges to 4. And we have a little look now. You can see it's created a whole load of new edges in there towards the border of in the edge where we cut it out with the Boolean. And that's going to make sure that we have clean geometry to go to Unreal. So we would also want to divide this up into sections so that we don't have to load the whole thing at once. And not only that, we probably want to apply some further poly reduction as we get further away from the playable area. But for now, we're just going to import this to Unreal and see what it looks like. So we create a ROP FBX output. We're going to leave the output directory as hip because that means look in the current project folder. And we're going to call this hip out. I'm going to call the folder render. And then I'm going to call this low res terrain. And we're going to leave that as a .fbx. I'm going to save that to disk. So now that's on disk. We've got our new Heightfield. We jump back into Unreal. Not flying into the clouds. I'm going to press Shift 2 to go back to the landscape mode. And I'm going to go back to the Manager tab, or the Sculpt tab even. And then with the Sculpt tab, I'm just going to hit in the height map, import from file, and we're going to re-import that height map. And now, because we've kept the same dimensions, we don't need to worry about offsetting it or anything like that. It's just going to import it with the new details. So there we go. We have a little look towards the edges of our terrain. You're going to see we get a little bit of weird texturing stuff going on, and that's because the polygon count of the projecting terrain is lower res than the Heightfield itself. But that's fine for now. We're not going to worry too much about that. We can clear that up in the future. The next thing we're going to do is we're just going to go ahead and import. Okay, so I'm going to go back to Houdini. I'm going to go to the ROP FBX. I'm going to expand this, expand that path. Quickest way to find a file. Paste that in here. And then we're going to go back into Unreal. And we're going to drag that low-res terrain in here. I'm going to leave it all on default for the time being. I'm going to pull that into the world. And you're going to see it's the wrong size. So we need to go back to Houdini, apply transform, and the transform scale between Unreal and Houdini is multiplied by 100 to take it into Unreal. We'll export again. We'll right-click that file and hit re-import. And then we're going to snap that to the origin, which should line up correctly with the with this terrain. So we may just need to apply a rotation factor to it. So I'm going to try in the Y, which is up in Unreal. I'm going to try applying a few different rotations. Oh no, okay. Try X. No. Oh, it's Z in Unreal. I got that the wrong way around. Let's try -90. No. How about 90? No. How about 180? All right. So what's going on here? Why can't I find the correct? I'm just going to go ahead and hide the fog. No. How do I hide the clouds? Let's grab the clouds. They are here. I'm going to hide the clouds for the time being. And I'm going to try rotating that again by -90. No. 90. -90. 180. Oh, I can't find the correct scale. So what's going on here? Okay, so the reason why that's not perfectly centered is because if we have a little look at the height field inside of Houdini, you can see that we haven't actually got this height field centered. So we've offset this to compensate for that. So we just need to offset it in the correct direction, and it's going to be a fixed amount by, let's try 25,000 or 50,000 or 250,000. So there we go. It's 250,000, and it's the same in the Y, or it's the opposite. So minus 250,000 there, and then we need to manually just drag it up and down in the Z-axis until it appears to fit. So when you're working with terrains this large, you'll probably need to change your scroll scale and speed inside of Unreal. So there's a few ways of doing that. The first one is if you hold right click and scroll the middle mouse forwards while you're flying around, that will speed you up. And if you scroll it backwards, that will slow you down. So that's what I'm doing there. You can also go up and increase the camera speed like so. And if you really want to, you can even apply a camera speed scaler to make it super fast. So I'm going to do that. And then I'm going to select this terrain and we're just going to fly to the edge. I'm going to try and get this to line up. So if you want to have a slightly more precise control at this scale, what you can do is you can hold shift while you're dragging the, you can hold shift and drag the widget here. And it's actually going to move up and down your camera at the same time as the terrain. So we're going to line that up as best we can. Cool. And for the time being, I think that I'm reasonably happy with that. I'm going to re-enable the volumetric clouds. And I'm going to go ahead into the exponential fog and just ramp that up ever so slightly so that we can get rid of that horizon as much as possible. And there you go. We've now created a massive open world, like massive scale world with no horizon that you can see. It's a really, really fun way to do it because you get the sense that it's actually like a real terrain. If we start pulling our lighting around like so, you get to see those glorious cloud shadows illuminating the far off terrain like that. It just looks really, really nice. So yeah, I think that's where I'm gonna leave it for today. We're gonna look at texturing it and doing a slightly better blend into the high resolution terrain around here. But we're gonna leave that for another session. So thanks again. Thanks a ton for watching. I hope that you enjoyed it. And if you did, please like and subscribe because that gives me a huge amount of motivation to go on and keep producing content like this. So until next time, and let me know what you think in the comments.